Good afternoon. I'm JooYoung Seo. I'm an assistant professor in the School of Information Sciences at the University of Illinois Urbana-Champaign. And I'm also the director of Accessibility Design Lab, where I design and develop data science tools, inclusive data science tools and practices with my amazing students and collaborators. And there's one more thing about me. I'm a blind professor who teaches data science and data visualization to my sighted students. So if that makes you pause, good, because it reveals an assumption that vision is the only reliable path to insight. Over the next 20 minutes, I want to challenge that premise. So let's think about it. What good is a chart that you can't see? How do you read a chart that you can't see? So now, when you hear these two questions, you might feel a bit puzzled. That's because the data visualization inherently assumes that you have the ability to see. We often can't separate the idea of visual ability from how we think about data visualization. For sighted users, data visualization is an incredible, powerful tool. So there's that saying, a picture is worth 1,000 words. And through data visualization, you can get instant insights and a much clearer understanding of complex data. It's a fantastic communication tool. But what about users with visual impairments just like me? For them, data visualization that assumes visual ability is like a wall of inaccessible information. It's a locked door behind which valuable insights are trapped. In that sense, data visualization becomes a barrier to understanding for users with visual impairments. So that's why I like to call this as data visualization divide. In our data science community, we've long tackled this issue with what I call a design for them approach. So basically, a sighted person creates a visual chart, and then as an afterthought, they might add a separate text description, also known as alternative text, alt text, for blind and screen reader users. But the problem with this design for them approach is that it creates just one-way street problem. So one group produces and sets the boundaries while the other group just consumes. Just consume whatever is handed to them. So this kind of power imbalance means that blind or screen reader users are just stuck within the boundaries defined by sighted creators. So now, I think it's time for us to shift from the conventional design for them approach to what I call design for us approach. So designing for everyone and making two-way street for everyone is a collaborator. So by the time I say this, you may think, well, that sounds like a great idea, but it also sounds a little bit idealistic. How are you going to actually do this? So that's a big question. So well, today I'm going to introduce you the solution. The solution is called maidr. It's a design framework that I've been working on for the past few years with my amazing colleagues and students at the University of Illinois. maidr is a multimodal access and interactive data representation framework. It decouples a vision-first assumption from data interpretation, and it encodes multimodalities into the data. So it doesn't create a separate or watered-down version only for screen reader or blind users. Instead, everyone uses the same tool, unified tool, and experience the same insight. So it doesn't give up on visualization. Instead, it builds on top of the visualization by encoding multimodalities like touchable Braille, readable text, audible sonification, and conversational AI. So let's take a look at each of the features. So first, you can fill the data using touchable Braille, touchable representation. So what that means is that we can represent data patterns in Unicode Braille. So for users with a Braille display, refreshable Braille display, they can actually fill the peaks and valleys of the data with their fingertips. As presented on the table on the screen, the idea is that as the data values increase, we use higher Braille patterns, and as the values decrease, we use lower Braille patterns. So this screen I'm showing you, it demonstrates how it works. And in the bottom right corner, you can see the hardware that people with visual impairments use. It's called a refreshable Braille display that can represent the Braille Unicode pattern physically so that they can feel through a fingertip. So next, we can listen to the data with audible representation. So this technique is called sonification, data sonification. What that means is that we can map data pattern into musical representation. So for example, we can map the x-axis to left to right stereo panning, and we can represent the increasing or decreasing Y values pattern with different pitches. So here's an example. On the left side of the screen, you may see a conventional, a strong positive correlation between X and Y variable. And this is what it sounds like. So you may hear the gradually increasing tone from left to right that can represent the positive correlation. Next, we can understand the data with readable text. This one is simple and straightforward. So what that means is that we can provide summaries or values in text format. And finally, we can chat with data using conversational AI and everyday large language model like GPT or Claude and Gemini. Okay, so I've explained all about maidr theoretically. Beyond theory, let's take a look and let's see how maidr works. So maidr in action. So today I'm so proud to be able to introduce a Python implementation of maidr. I'm sorry for R lovers, but here are three very simple steps to create a multimodal representation. Step one, import maidr package, which is available in PyPI. And step two, create your plot using matplotlib or seaborn. And step three, show using maidr.show just like how you do using plt.show. Just like this Python code. So part 1 and part 3, these are the two simple changes you need to introduce to your existing code. So you may have a question mark, oh, are you kidding? No kidding. Actually, this is really all it takes. And once you use these two simple lines of code, your existing matplotlib and seaborn chart will be automatically translated into multimodal chart. So this is just a keyboard shortcut key. Once it's rendered into your web browser, you can toggle on and off Braille using single letter key, B for Braille, and T for text, and S for sonification, and question mark for AI chat. So let's take a look at some examples. So we have a conventional multi-line example written in matplotlib. And once it's rendered, it creates interactive SVG chart like this. So I'm going to switch my sound card so that you can hear my screen reader sound as well. Give me 1 second.
Headphones real audio. Frame. This is a maidr block of time. Multiline with 3 groups. Use arrows to navigate data points. Toggle B1. Off. This is a maidr block of time. Multiline with 3 groups. Use arrows to navigate data points. Toggle B for Braille. T for text.
So I'm going to use left to right arrow key.
Years 1950. Years 1950. Years. Wait. Let's voice name equals total voice code radio bracket slash voice rater. Years 1973. Index is 100. Let's voice name equals total voice code radio bracket slash voice rater. Years 2007.
So it has 3 lines.
Years 2007. Index is 197.77. Group is population index.
Population index.
Years 2007. Index is 114.86. Group is life expectancy index.
Life expectancy index.
Years 2007. Index is 332.39. Group is GDP per capita index.
GDP per capita. So each line has distinct audio.
Let's voice name equals total voice code radio bracket slash voice rater. Years 1950. Let's voice name equals years 1960. Index is 1. Let's voice name equals total voice code radio bracket slash voice rater. Years.
So that blind people can see, hear with a musical note. And then it has Braille representation. I just press B. So when I move around, the Braille representation is synced with a visible highlight. And I can even have a conversation. So when I press question mark, describe this to a sorry, I'm person and hit enter, and it's processing.
I'm ready to describe the visualization for you. Here's a breakdown. Start with raw description. Start visualization is a line chart that shows how 3 different things have changed over time from 1950 to 2007. The horizontal axis represents the year, and the vertical axis y-axis represents the index value. There are 3 lines on the chart, each representing a different index. Start life expectancy index, start GDP per capita index, start population index, start individual line description, start life expectancy index. Start line starts at 100 in 1950.
So we send the same prompt to 2 different models, AI, OpenAI, GPT, and Gemini, and even users can configure the model. The reason is that blind people cannot easily verify, so that by giving them multiple responses, we wanted them to have more informed decision.
Escape. 1. Virtual PC. No buttons. No buttons. No buttons. Escape. Navigation region. maidr. Empowering accessible. Code. Box plot import maidr.
So what about box plot? So box plot is also rendered in the multimodal format. And this is a Braille. And you can compare GDP per capita between Africa and Europe using different tones. So this one has higher tone. Yep. And what about multi-layer? So this is a histogram having 2 layers. The second layer has KD, kernel distribution estimation. We can move between layer by pressing page up or page down. So this is the first layer. This is second layer. So second layer, first layer. And all layer has a Braille representation as well. What about more complicated example like multi-panel subplot? Yes, it's completely accessible. So I can move around between subplots. Shiny, yes, it's supported. So we have added custom render, maidr render. So once it's rendered, Shiny is made fully accessible for the matplotlib and seaborn. So you may wonder how this is possible. What's happening behind this magic? We use 3 different layers. So we capture, we intercept the matplotlib and seaborn, and we extract their data, raw data, and we bake the raw data into SVG. So, and with audible, sonification, Braille pattern, and we have developed our core JavaScript engine to make it accessible. So, oops. So you may wonder whether there is any performance issue when we use this monkey patching approach. Actually, the performance overhead is very manageable, so you can ignore any overhead because for matplotlib, it's only 1.48 millisecond on average with maidr. So this is literally nothing, so millisecond. So for matplotlib, it's 1.48. For seaborn, it's only 3.26 millisecond overhead. So practically, this is nothing. So as I demonstrate today, it's not only working for matplotlib and seaborn vanilla code, but it supports reactive dashboard like Shiny and Streamlit. And what about reproducible document? Absolutely, it supports Quarto because I made this slide with Quarto. And what about interactive computing? Interactive computing like Jupyter Notebook and Google Colab? Yes, that's supported. So it's time for us to build the future together. So maidr is not just about tool. It's more than tool. So this is about different perspective. So it's about fundamental shift in how we think about communication and visualization. So please build the future together. You can start today. You can just pip install maidr in your terminal. And its source code, open source contribution is available on GitHub, and its user manual is also available at py.maidr.ai.
JooYoung, I'm so sorry to interrupt you. Would you like to make an end to your presentation, or would you like to make a question?
Yeah, this is my end. Yeah.
Very well.